Good, Raghu.
Okay. I think most. So his vaccination is done with everyone.
Yes, Raghu, it's done. First two.
Oh, okay. Congratulations.
Thank you. For you?
Not yet. Probably I'll be taking in a week or two.
Okay, okay.
Yeah. So is it like Covishield or Covaxin?
Covishield.
Okay.
Didn't get Covaxin, yeah.
Anything is fine. Yeah, as long as that we got the 2 shots.
Yes.
So let's get started. Can you see my screen?
Yes.
Okay. Yeah. So Kubernetes, or in, people call it as like K. It is so both are same. So it was actually in the short form people call it as like K. It is. So yeah, some of you might be already known or we already discussed. Kubernetes is developed by Google, one of the popular orchestration tool. So which basically helps to maintain the container orchestration. We'll discuss about so this containers and orchestration. But anyway, by this time, I think most of you know what is containers. Just as a recap. So why do we need containers? Basically, just to isolate the components. For example, on hardware, so if you want to install multiple components, you generally require libraries and dependencies on the top of OS. So the problem will be that these libraries and dependencies will be shared, the OS will be shared, right? And there'll be some components will be talking to the hardware. Compatibility issues will be coming here. So this is one of the complex metrics. We'll be doing firefighting, installing multiple components, multiple or the prerequisites libraries here and there. So to address these problems, one is compatibility, and then looking for some long-term setup. And then when we go from environment to environment, so we will are facing the challenges. So the solutions for the containers, what it can do, we have seen. So containers can be kind of isolate this stuff. So when we containerize applications, they run all those components in its own isolated environment with all the dependencies. So you can have your own libraries, you can have your own dependencies, which will help to separate the containers running on the same machine with the help of kind of like Docker engine program, etc. So, yeah, what are containers? Yes, just definition. I think containers applications will be running in an isolated platform. So that, for example, if you want to deploy 6 to 7 applications on the same machine with the help of Docker engine, yes, you can build an image and you can deploy the container there. So it also we have learned that it is not a new. It is earlier. A lot of vendors also they developed, like for example LXC, you might have heard about it, LXD, Rocket. So many container solutions were there in the market. Docker, of course, it used this LXC from Linux. Basically, it was developed in the Go language, so it uses that particular LXC mechanism. So and then yeah, of course, basic of operating system we have discussed earlier, and wherein sharing the kernel was done by Docker. So Now, some people will be having a question. Can I also virtualize OS unlike hypervisor? Here, no, Docker is not meant for OS or virtualizations, right? Basically, if you compare the earlier hypervisor model and the OS kernel model, so you'll be having a physical server, OS, and the hypervisor and deploy the VMs. But when you're coming to the container side, you remove the guest OS, you remove the hypervisor, you just install the kernel. Differences: lightweight containers, OS installation is not needed, CPU RAM storage is not needed. You can have more containers compared to VM. Portable will be there. And we have this Docker Hub, which is a public image repository wherein you can search for any type of images from different vendors. They have their own repositories. For example, let's say Redis, Node.js, Nginx, MongoDB, etc. So these are some of the repositories here. So Docker containers and images, yes, of course, images are read-only here. And then containers, they actually run form of this particular images. Advantages: less overhead, less system resources of the container. Portability is there. Consistency in terms of operations, particularly when you adapt DevOps, greater efficiency. And developer now can, or system, I would say, can focus on development rather than working on CI/CD, working on configuration management, working on what you call consistency across all the environments, etc. So to manage all these things, we need orchestration tool. So when you say orchestration, I'm not talking about a single node where you deploy the containers. You might be having cluster of nodes. For example, yesterday we have seen Docker Swarm, which is a tightly integrated orchestration tool from Docker for Docker, by Docker for Docker. What do you mean by that? I mean, I cannot use any other container in Docker Swarm. Yeah, this is just an example. So orchestration tool will help us to deploy the containers, scale up the containers across the nodes, or if any physical node is having any issues, okay, it will immediately ship those containers to scale it up and scale it down, etc. Here. So why do we need orchestration? Yeah, we need orchestration to scale up the containers, handling failures, and managing the node, that physical node or a virtual machine or a cloud machine. It is a material. Maintaining that node, performance of the containers can be monitored there. Basically monitoring those containers, etc. Writing some scripts, all that stuff. Give me a minute. So yeah, and that's back. These are the advantages and the need for having an orchestration. Now, some people says that so we can also do with the help of some tools and scripts to handle this broad environment, and then handling those failure containers, deployment of those applications and containers. So this scaling up, these are all that can be done with the help of containers here, right? Then why do we need an orchestration tool? So you can also like now automatically adding some additional hosts. All that stuff can be done. No? But with scripting, we can't do all this particular stuff, right? So we need some kind of a ready-made solution for that. So advanced load balancing, sharing storages, and then coming to the support configuration management and clustering, deploying those applications inside the containers. So all that possible with the help of this kind of container solutions here. Now in the market, do we have only Kubernetes? No, there are n number of orchestration tools available. So you have Amazon ECS, right? Elastic Container Services. You have Azure Container Services, and then you also have Docker Swarm, which again from Docker. You have GCE from Google Cloud Platform, and then there's open source tool Docker Kubernetes, and then you also have CoreOS, Fleet, and then I mean the list is very big. So you have Mesosphere, Cloud Foundry. Some of them are open source, some of them are enterprise editions. OpenShift from Red Hat. There's one more thing. So of course, that is again Kubernetes Enterprise Edition. So these are some of the solutions and all these things from the orchestration tool. So any one of you worked in any of this orchestration tool? Or like Amazon ECS, Azure?
Yes, Raghu, I'm working on AKS, Azure AKS cluster.
Okay, Azure cluster. Oh, is it?
Yes.
Okay, this is Vikram. Okay. Any one of this? I mean,
yeah, Raghu, I worked in Kubernetes recently.
or directly open source?
EKS is not there in this.
Oh, okay.
Yeah.
Yeah. So actually, I have another document where, like, which will explain you, why Kubernetes is the best choice. But again, I'll just try to summarize. Not sure if it is there in this slide. Let me see. Okay, I think there are some slides about talking about each orchestration tool. So fine. So then at the end, we'll try to discuss about that. So we have this Docker Swarm. This is by Docker, easy to get started. Okay, but what it is lacking is some advanced features. For example, auto scaling. Yeah, you can scale up the containers manually, but no, auto scaling, that option is not there. Just to give you one disadvantage. Also, as we did know, in Docker Swarm, we cannot host, let's say, LXC containers or LXD containers or packet containers. It is tightly coupled with Docker. So that is one disadvantage. Now Mesos, this is from again Apache. I never worked it, but I read from sources that difficult to set up. So this Mesosphere comparatively, but yeah, it supports a lot of advanced features which can like Kubernetes and etc. And then this Kubernetes again. One that the backend, the logo is that Google. So they have around close to a decade of experience in developing Kubernetes in their in-house. 2014 is when they made this as an open source and handed over to CNCF, Cloud Native Foundation. We'll talk about that later. But again, when you say setting up Kubernetes, yeah, I still feel that when you're trying to set up an open source Kubernetes on a VM, it is comparatively little difficult to set up. A lot of steps you need to follow. But again, this is advanced features it supports, and then you can customize the deployments based on the application requirement. And this is one of the other feature that it supports many different vendors from different container platform. Also, most of the leading cloud providers, for example, GCP using Google Kubernetes engine. Again, now this is Google Container Engine. And so whatever you name, GKE or this, all these things, all this again in the background they are using Kubernetes engine. Even AKS, Azure Kubernetes services, or even if you look at AWS, Amazon Kubernetes services. So that is all these leading cloud providers they supports Kubernetes as a service inside their portfolio. So this is one of the top ranked project in the GitHub. Like when it is also announced to Kubernetes, it says that no, they supports around close to 1,000 nodes cluster when it was announced. I do not know what is the current number, but yeah, that was the one of the other advantage of the Kubernetes side. So some features of Kubernetes, yes, yeah, I think this point is already there. So you can run up to 1,000 instances using single command. And in case if you want to add 1,000 more, yeah, you can add one more command. Auto scaling is possible. And when you're looking at the deployments, you can go for rolling updates. Also, you can go for AB, or we call it like green blue deployment to test your applications. And this Kubernetes open architecture supports different network and storage vendors. What do you mean by that? Let's say you're looking for physical volume to be automated from a different storage vendor. So yeah, it can support. There are a lot of drivers available, or the vendor will come with some drivers along with the network. So there are different kind of network solutions also available inside the Kubernetes architecture to integrate with the different kind of networks. And n number of plugins available from different vendors. So, and when if somebody is saying that this is Kubernetes compatibility, that means that they are saying that they have the driver already available or the plugin available to interact with the Kubernetes. So because of the wide reach of this particular Kubernetes to the multiple users, vendors are now bound to develop some plugins to talk to this particular product. And it supports a lot of authentications and authorizations also. So this variety of when different systems are available. These are some of the features of Kubernetes. So now relationship between Docker and Kate. Yeah, Kubernetes uses Docker host to host the containers. It need not to be Docker all the time. Last November, I guess, they announced that they are withdrawing Kubernetes as a inbuilt container engine when they are going for deployment here. So otherwise, it supports a lot of alternatives also, Rocket, LXD. You can there are shems available like Docker shem, which can deal with that particular stuff, or Rocket shem, LXD shem. We can go ahead and deploy, so that now you can also have those kind of containers inside the Kubernetes. This anyway, I'm not going to discuss. So now the prerequisites, if somebody want to learn Kubernetes, is that yes, you need to have Linux knowledge, and you have to have container technology knowledge, and then you also need to have application support knowledge, because how the application works and all these things is required for you to set up some deployments there. You are looking for some certifications. There are some certifications available. A certified Kubernetes administrator CKA course, I think $300 is the fees. One free take is available. So this will help you to provide some pretty good knowledge and skills and competence to perform some good responsibilities from the Kubernetes administration point of view. Apart from this thing, CKAD is also there. Abbreviation is Certified Kubernetes Application Developer, around close to $300 again. So which will help you to understand, design, build, and configure and all this stuff in the Kubernetes. Yeah, so doesn't mean that CKA is for developer. No, it is both are having some different purposes. But again, so this all talks about the container application deployment, etc. So one can take anyone. So if you ask me, I will say that start with CKAD and then go for CKA. Because CKAD is having a 66%, and then CKAD, I think 75% of the marks you need to score to pass the exam. So let's first visit Kubernetes Wiki. So this is 2014. It was initially released. Okay, so not that it is there in the market for a decade. Sometimes when I used to see very nice, job description that we are looking for somebody who's having 10 years of Kubernetes experience. We should actually, share this screenshot with them. So it came into the market 2014, but yeah, Google, in-house they've developed this thing instantly, and then right now it is developed by Cloud Native Computing Foundation. We call it in a short form CNCF. Who are the persons right now or conducting that CKE and CKED Linux Foundation, basically written in again Go language. Docker is also written in Go language, right? So this basically is the cluster management server. The current edition, I guess, let's scroll down. Yeah. So last April, I think they've released 1.21. That is the current edition. Otherwise, the stable, I think, in the market industry, I have seen people are using 1.18 and 1.9 or 1.9. They still not yet update a lot of customers. Yeah, a lot of people are using 1.18. Slowly they are moving into the 1.19 now. Now, this is about the visualities of the period, which it was supported and etc. Yeah, so 2019 going, yes, as in when I think by 2022, I think they're working and developing this the X number of versions there. So let me get into architecture of the Kubernetes. I have some slides. I don't know if it is still there or not. This document will help us. Just to quickly walk through about the Kubernetes. Yeah. So Kubernetes is basically a lot of collection of multiple services or stack of services. They all work together to manage all the different hosts. And so the smallest unit inside the Kubernetes is pod. So it can accommodate a container or more containers also, such as your Docker containers. So it is basically overlapped with the pod. So we'll talk about like why do we need pod again for because anyway we have containers, etc. So many things, right? We'll talk about that later. But this is the pod, basically which also have an IP address. Now on top of this, you'll be having a service. So this pod, I just mentioned that it will be having an IP address. This is received by service. So this IP address is a dynamic IP. So it is difficult from outside if I want to access the application inside the container, which is deployed in the pod, which is having a dynamic IP, because we never know this pod anytime can go down and a new pod can come up because you probably will be defining that in the services that, hey, I need to have at least 2 pods. I mean, talking about single machine. Okay, so in those cases, it will be difficult for us. So my service will be having the static IP. Will internally talk to this particular pod. Now, can I say service is like a load balancer? Yes. So you can probably can say like that. So it acts like a load balancer. So no matter on which node the pod is running under this load balancer, what is the IP address, so that that is all it will be taken care by the service. Okay, we have seen the pod and service now. Now, if you look at the architecture cluster setup here, 1 second. So you have a master node, and here in this case, 2 nodes are available. Now, unlike your Docker swarm, you will not have any containers or any application stuff deployed on the master. Everything will be deployed on the nodes only. Now, what master contains? Master contains probably an etcd database, a scheduler to deploy these parts, managing this entire pods or the nodes, and you as a developer or DevOps engineer will be talking to the master with the help of a API, like an application programming interface. So this is the only way you can talk to the entire cluster as well. Now the application which are deployed in the pod here, if you want to access those pods from outside, master will not come into picture. You will be having kubeproxy, which will be exposing these pods to the users. For example, if there is a URL available, so the URL will be routing to this particular cluster, and then kubeproxy will handle this incoming request to map to the respective pods to serve the applications. Now this is very high level about the architecture. Now let's go little from 10,000 to 5,000 feet. So you'll be having a master where, and these nodes we call it in the Kubernetes language as minions. Here inside these minions, you will be having engines. The Docker engine will be there. Anyway, we have seen this, right? So you'll be having a pod, and then that pod will be having these containers here. That is we know, right? So master will be managing this entire cluster here. So how it will be doing that? So you will be having an agent running inside the worker by name called kubelet. So master will be talking to the kubelet for deploying or scaling up these pods, or maintaining the desired versus the actual running states, anything you want to do. So accessing these again, the containers is again from internet is through kubeproxy, which is there in the nodes. That is different story. So every operations will be recorded in database called etcd. We call it as, I think, a key pair database. What is key pair is that only 2 components will be there, like your MongoDB or Cassandra. So you'll be having only 2 components: the key and the value of the object stuff. So everything will be recorded in the etcd. So with the help of etcd, yeah, all this kubelet, all this etcd, and then scheduler, container managements will be talking to each other. So you will be having a kubectl installed on your laptop or your desktop or any other machine through which you can connect to this cluster. Kubectl is probably a program which you have to install in your machine, which can through which you can probably talk to the master, and then probably, can we say an API? Yes, kind of, yeah, CLI or API, which will help you to configure this particular stuff and do performance management, etc. So what are the, now that is about all the high level. Let's go little in deep now. When 2,000 feet will come down, and the master node, what are the components will be having? We have seen etcd, key value storage. So this is again an open source component developed by Core OS team. With what it will store the entire configuration of all the nodes, such as the jobs we schedule, or a deployment of a pod as service details, or a namespace, or any replication controller. These are the information available on the etc stuff. Now, if you look at the API server, what it will do, it actually validate the configuration which was stored in the etcd, and it will basically just in another language, syntax check kind of stuff. I mean, in layman language I'm talking about. So it also provides a RESTful interface to make the communication easy. So etcd and API server, two components in master. Now the third one is scheduler. So it will check this, what is the requirement of the container which we are going to deploy. Now it will also check and which node it has to deploy, because in case if the container or a node is already overloaded, it will just verify whether this container can fit or not. So scheduler will take care of deploying this particular, not deploying, basically identifying, scanning the nodes and all those things. And then it will inform the agent called kubelet in running inside the node to deploy the pod. Now the other one is kube control manager. The responsibility of this kube control manager is managing the cluster level functions, such as replication controller. So whenever a desired state of the cluster change is written in the etcd, it will try to bring up the cluster as per the desired state. It also watch the state of the cluster, and if there is any corrective changes being to be desired one, it will try to adjust that. So replication controller, which takes care of the pods in the system. If any pod fails, replaces that with a new pod. This is just one component in control manager. So that is all about the master node. Now from the minion side, minion in the sense worker side, in our Kubernetes language, node wise, Kubernetes node. Yeah, you need engine. So Docker engine will be there. And then kubeproxy required. Why? Because from internet, if somebody were trying to access our application, yes, you need that kubeproxy. Kubelet is an agent. It will run on the each node, responsible for managing the all stuff. So it can deal with the pod specification defined in YAML or JSON format. We have learned about networking also, the planner. So this is overlay network. I mean, what do you mean overlay network? Basically, it will be having its own network on top of your Kubernetes. On top of that, wherein you can spin up the containers. So it works like an assigning range of subnet address. So assigning those IPs to each pod running in the cluster. And in case if they want to talk to each other, pod to pod or pod to that services communication, everything is done by the planner. Any questions so far on this Kubernetes architecture?
Raghu, the example we are going with is Dockers, right? Usually
the containers can be from other sources also, where we can use Kubernetes.
Correct. Yeah. Yes. Okay. So let me move on to the next part. Now, architecture, we got an idea. Let me close this documentation. So let me start with some basics. Yeah, setup. So installation, we'll talk about now. Now, when we look at the setting of the Kubernetes, yeah, so you have a lot of different solutions. If it is in the local environment, so you can go with a mini cube, wherein on a single node you can install the Kubernetes. But it is not a production grade installation. If you are looking for a production grade installation on a single node, then you go over this installation called micro Kubernetes. Micro gate is called it as, or Cube ADM. This is very popular at the enterprise level. So we have a VM, multiple VMs cluster. Let's say 10 nodes, 20 nodes. You go with this Cube ADM installation. So all these are on-prem environment. It is immaterial whether a single node, production grade, or multi-node. Now the same services it is offering by cloud providers. They name it as GCP inside your Google, AWS we have seen, AKS, Microsoft Azure again, and Azure Kubernetes services. Now the problem will be for practicing purpose. So now we need at least one node. I mean, that's fine. We cannot have multiple nodes now at home to practice. So that it should have at least 4 GB RAM and 2 CPU core. These are the problems. Even yeah, the only way is that the better you go for your Windows laptop, see if your hypervisor is enabled and all these things, and try to download Oracle virtual machine. Go for some ISO files, Linux files, and then start working on setting up at least that mini cube. So this is mostly people will be using mini cube on your single node and a single laptop. Or if you ask me, any paid Code Cloud is not free, but I think there are some modules which are free. So you can also practice on the Code Cloud. So I'll show you some of the Code Cloud practice sessions. But just to give you an idea, as you can use a lot of other solutions also available on internet, search for it. When I've seen Code Cloud is the best one for Kubernetes learning point of view. We'll spend on Code Cloud also, no problem, don't worry. Now, if you look at the Minikube stuff, I told you, right? Minikube is what we were going to install and practice on a single node. So you don't need again cluster and all that stuff. Everything is bundled here. So generally, what we have seen in our architecture, you will be having a master, you'll be having a worker node. And the worker node, majorly two components. One is CRE, container runtime environment like Docker, or kubelet, and kubelet, sorry, which is like an agent. Now on the master side, database is required etcd, and then you need a control manager component such as node controller, replication controller, and then to talk to this cluster, you need an API, kubectl, to interact with that particular stuff. cube, you need that particular stuff, right? So these are the things. Now, what do you mean by mini cube? Bundled together. So you have kubelet, every year in the same node, cube API, etcd, node controller, replica controller, container runtime, everything is there in Minikube. So Minikube is a product wherein you can install with 2 GB and 4 GB RAM machine and practice Kubernetes on that. So can I install in my Windows laptop? I'll show you. What do you need to simply check it out? That just right mouse here, go for task manager. I just need to check it out. One thing, if you go to the performance and the bottom right, see here in my BIOS, it looks like virtualization is disabled. So you need to enable this thing. You probably refer your laptop documentation how to enable that. It varies from laptop to laptop. So disable, you need to enable the virtualization and then download this virtual box. Oracle virtual box, you can download it. And then you go to an ISO file and download that ISO file. Any OS, Ubuntu, CentOS, anything. I think the size is around 1.5 GB. It's OS ISO files I'm talking about. Mostly the VMware guys, they might be knowing what I'm talking about. So you can do that particular stuff, and then what do you call? You can go with Minikube installation. You need to install kubectl. What if you have a Linux laptop? Then you need this KVM again, and in Windows in Hyper-V. In Linux, you have to install KVM, and then again same stuff, virtual box. The 3 components required here outside of this particular Minikube is kubectl, one to talk to this cluster, and then coming to kube installation, you need minikube.exe, that software, and then hypervisor. This is one way mostly people will practice on your laptop. Any questions?
Raghu, you are waiting for everyone of us to respond.
Yeah.
All right.
Meanwhile, the reason I'm just giving gap, right? Because a lot of the people generally busy with their mails and all those things.
All right. And Raghu, one question. So here on our laptops, you mentioned like how to figure out whether virtualization is enabled or disabled. We can do this activity on our cloud instances as well.
Yeah, because T2 micro you cannot do. So you have to go for T3 micro, which is chargeable.
Okay, fine.
But that is fine. Generally, if you want to do that, you can please do that. So no problem. But there will be little charges. It's okay, worth paying that money.
Yeah.
So I generally practice Untitled Micro only because this machine, laptop machines are very slow comparatively.
All right. Okay.
Because my machine, I think it's 8 GB, 4 GB now. So it will actually not responding as expected, like T2 Micro. That is one of the reason. Generally, I use T2 Micro. So per hour, I think for 2 hours, it's INR 11 rupees something. It's charging me. It's okay because as soon as I'm done, mostly I'll be delivering trainings. No, as soon as I'm done with the training, I used to shut down those machines.
Okay.
But if you use Azure and all this thing, yeah, again, you can what do you call, go with those virtual machines, because anyway it is worth $300 will be credited to you, right? That is a the other way of handling, no? So you should not be having any issues.
Yeah, we can use any service until that credits are over.
Exactly, correct. Yeah, one advantage will be there. One second, just sending you an email. Okay, so let me see if someone can help in quizzing, answering these questions. Let's see how many are attentive. Which of the below is an option to run Kubernetes in a local environment? kubectl, kube server, minikube, or play with kubernetes.com?
Minikube.
Okay, the second question.
But kubectl also, Raghu. I mean, we can do with kubectl also, right?
kubectl is like, connecting to the cluster.
Yeah, but with RBAC we can do, right? I mean,
yes, you can do that, but yeah, here is like, not to that detail. So just a minikube
okay.
will run. Yeah. Then the cloud part, yeah. So we know Google Container Engine. This question. Question number 3.
KubeADM.
KubeADM, yes.
Yeah.
On-prem. Yeah, so this we were talking about now, how to install minikube. So you can, this is an official documentation. I'll just walk you through. I think I already have one T3 micro machine minikube installed. So, but otherwise, I'll just walk you through that link, how to install and all this stuff. You can download the Oracle VirtualBox from this link. So for Windows, you can go to that reference. So only one thing is that when you are trying to use minikube within a virtualization technology, try to use this option VM driver. You need to provide the driver name. So in case if you don't have any driver name, T3 micro, right? You have to use none. So otherwise the minikube will not come. So you have to use that VM driver. So this is something which I actually pulled from one of the training lab setup, I guess. Let me see, is it still valid or not? Cloud. You can use not working. Yes. I think this is still valid. It seems. So you can directly practice here also instead of D3 micro setting up like that. Loading code cloud. Nice. Okay, so how many nodes are the part of the cluster? Yeah, maybe some of the persons who are already working in Kubernetes, they can help. So the question is, including the master node, how many nodes are there in the cluster? So that is what they want to know. So what is the command we can execute? So kubectl is actually I told you CLI, which you have to use. Anyone? Kubernetes person?
It'll get nodes.
Kubectl get nodes, yes. So or you can click on this hint. You have this answer. Kubectl get nodes. So like your Docker, no? A Docker where you use Docker commands, right? Docker space, Docker init and all this thing. In Kubernetes, kubectl is a command. Now, where do you run this thing? On a master or a minion? No, not on master, not on minion. You will be installing in your, as I said, local laptop or your desktop or a workstation or any other cloud machine outside of Kubernetes, and you will be talking to the cluster here. Okay, not on the master. So here, yeah, kubectl get nodes is answer. Now the question is, how many nodes are part of the cluster? What is the answer?
One
Node. This is control plane. Yeah, master node. You could say that master. Okay. Let's check it out. Is it correct or not? Incorrect. Shall I try to? Yeah, two is the right answer.
Master and worker.
Yeah. Now, what next question is, what is the version of Kubernetes running on the nodes? I think it is there now, fifth column.
1.19.
19, yeah. So what is the flavor of version of OS on which the Kubernetes nodes are running? This, you can look in the hint. So just to use void command. What is exactly it will do is that the same command in the previous, but it will give you more details. So it was a trimmed output that this is a wide output. So here, so OS image, it is showing us Ubuntu 18.4.05. This one. So with this command is very popular. Kubectl get nodes, wherein you can get the what you call Kubernetes version, number of nodes, what is the how many nodes are there, and what is the OS version. Okay, so we know Ansible, right? YAML and all these things. We have. I'll probably will skip this thing, but because anyway the presentation is there. Let me quickly give you Kubernetes language, how it looks like, a YAML basics actually. But I know some of you already know experts YAML here. So if you're familiar with XML and all this thing, YAML can easily pick it up. Let me give you a very brief about this thing. For example, in the YAML, let's say you have a animal dog. So there are two types of dogs. This is how you'll be defining dog 1 and dog 2. Also, if you look at the second bottom section, so in case if there's a person name, first name, last name, spouse, how many dogs, so everything this way also you can write in the YAML language. So how this YAML language generally is, it is basically there are like the key components. One is key value pair. for example, and this column, it says that no, fruit is apple, vegetable is apple. So this is two components, a pair value. What is it? Liquid is water, meat is goat, and all this stuff. This is one thing. It is a key value pair, one of the feature. The other one is if you want to set up some arrays or list, we call it as. So this is how you can say fruits are, these are fruits. Vegetables, these are food, these things. How do you do that? Indentation is important. Because YAML is developed in Python, no? Same here. Ansible also we have seen this problem, right? I mean, why I'm saying problem because I always fight with indentation. Because I'm not a Python expert. That is the reason. Yeah. So arrays are list here. This is you need to follow. And in case if you're looking for some dictionaries map, this is the one. So wherein, for example, I'm trying to describe banana, what it can give. So this is calories, fat, carbohydrate, so grapes, calories, fat, carbohydrates. These are the things which you will be defining here. So even it is also the same concept in Perl also. In case if you know Perl also, where there is dictionaries available, arrays is there, the same stuff in YAML. So more detail about this dictionary, banana, this one, and this one. So generally, I will say that whenever you try to define any Kubernetes YAML file, you better use this 2- concept. So try to give 2 dashes. It will be easy. Don't give any tabs here. So you need to give equal number of spaces here. So now if I want to put an array as well as dictionary. So under these fruits, there are 2 arrays, banana and grapes. Under this banana, this is dictionaries. So dictionary or list of dictionaries. So take an example. You have a car. There is a color for that. Which model, name and year, and the auto or manual transmission, the price. The same thing if you want to write in your YAML. This is how you generally write. Color is blue. This is name. Year is 2020 model. I think Alto is the 2020. Yeah. Transmission manual. This is the price, approximate price. Now, if I want to add two cars, multiple colors. So let's say that white color, marine color, black, Alto, etc. This is how you write. Color, model, transmission, and then is the price. The same code copy paste. Color. The color is the only thing which will be different here. The remaining thing is probably same. And this is black, and this is the same stuff. Of course, forget about this indentation. This is, I think, while I'm developing this presentation, PPT, my term is here. But still it is valid. Now, take this example. Banana, here it is calorie, but under this fat and carbohydrates. So order here. If you look at this one, will it make any change in the execution or understanding this program? No. So even though they are unordered in the dictionary, both are same. There is no change. But if you look at arrays, so let's say this is fruits, orange, apple, banana, and this stuff. This list is here. They are not same. Why? Because here when they're executing, probably the sequential order matters here. So because the order here it is different, both will not be follow the same structure, same way. So in arrays, this is you need to remember. So yeah, this is one more example. I guess the fruits, these are the things. Vegetable, these 3 things are there. List example. Now, yeah, here is one is employee, and this is all about his details. This is again same stuff. Yeah, this is one more array here. What are the projects he worked under that? When he worked on automation, worked on support. You can also, let's say there is a requirement that we need to add pay slips. I can do this way also. Under projects, this is anyway, we have seen, right? Arrays. So under payslips, yeah, this is 1, 2, 3. Why not 6? Why? Because this hyphen is very important here. So this is entire one entry. So month June, so this is a base. Month of July, this is a base. This is August, this is a base. So this is entered in this thing. Yeah. So we have seen pod, right? Pod is the smallest unit in your Kubernetes. So can I create a pod? Yes, we can also create a pod. There are some definitions about the pod. We'll talk about that probably this one more presentation. Let me come to this section and then I'll come to this one. First, we'll try to learn what is pod. So we have seen in the Docker, we have images. They're available in the hub. And then assume that now you learn about setting up Kubernetes cluster, which we'll be doing in T3 micro machine probably tomorrow. So wherein we have set up the cluster. It's probably would have set up in Minikube or a multi-node, all services and all these things is running. So assuming that you have set up the cluster. Now here inside the Kubernetes, if you look at a pod, Kubernetes can be a pod collection of multiple nodes. Now inside that you have a pod. Inside a pod you have a container. So the only difference majorly here, if you look at the Docker images and this way, that you have this new component called pod is available. So as I said, why we need pod? Yeah. Here, generally in a single container, yes, of course, here it is available. But when you have a pod, it also can accommodate more number of containers also. So you can, let's say, link them in case if you want inside the pod. The advantage is tomorrow, if I want to scale up, now the entire thing will be scaled up. So let's say that you have two containers, they are linked together. That entire things can be scaled up. That is one advantage you have in the pod. And it contains how to link this one containers, volume one, everything is bundled here. And this particular pod will be having an IP address. It's a dynamic IP. Why? Because if pod dies, you get a new pod, it will get a new IP. Who will provide? Service will provide. So you cannot directly talk to the pod. So you have the service, which is like load balancer, which will manage the incoming traffic and route the request to the pod, because it is the one who actually allocates IP address to these pods. So act like a load balancer. But inside a pod, can I scale up the container? I mean, so when let's say that no, user base increased. No, it's not. I'm not saying not feasible, but it's not advisable. Always try to scale up the pods only here. So you probably want to spin up another pod in the same node, that is fine. Or you want to spin up another pod in another node, yeah, that is also fine. But don't try to spin up multiple containers in the single pod. Why? Yeah, this is what I was talking about now. So let's say there are two containers linked with that. They have linked, established a communication, all these things. So these are the things we call it like multi-container pods inside a multi-containers inside a pod. How do you deploy a pod? So we use the same command kubectl run nginx, and what is the image? Now from where it will download? It will download this image nginx from Docker Hub, and it will deploy a pod, and inside the pod it will deploy a container with that particular downloaded image name called nginx. So basically it will pull the image from the public hub. So now, can I also configure Kubernetes to talk to my company rent repositories? Yes, you can do that as well. So if you want to list how many pods are running in your machine, you use this command called kubectl get pods. It will list all the number of pods running inside the cluster. So let's do one practice here. Let me spin up my Amazon T3, but how many slides are there? Okay, let me finish this thing, then I'll come to that. So these are some of the commands. For example, kubectl run nginx image nginx. You'll be doing here. So it will spin up a pod. Get pods, list the pods. Now, what is describe will do? Describe will give more details of this particular pod called nginx, such as IP address, the container details, or the event logs, or the from which image it was pulled and deployed this thing, the status of this, everything will be displayed in the describe pod command. So very for troubleshooting purpose, describe is very more frequently used command here. So get pods -o we just now seen now will give the detailed output that in which node it is running, etc., etc. Okay. So the smallest unit you can create in your Kubernetes object model is answer is anyone?
Pod.
Yeah. So a pod can only have one container in it. Is it true or false?
False.
False.
So you can have pod more than one container. What is the right approach to scale an application?
Deploy additional pods.
So even though you can have multiple containers in the pod, generally in the model, the Kubernetes platform, it is nobody will prefer that.
One container in one pod is the best practice in this.
Yeah, correct. So we can use this command. I have spin up the micro Kubernetes machine. So just I just preferred D3 micro. I've just installed Minikube, but Minikube on. Okay, I think I've chosen Ubuntu, but anything is fine now. So we can probably go here, I guess. Lot of documentation is available. Just go and wherever you want to go. So but yeah, I think the 4 GB is recommended. This is the traffic space is required. So this is the minimum thing you need. So for example, you want to install on Linux 86 model, some commands are there. You just need to install that software called Minikube. And this is how you start the cluster. And this is how you'll start this thing and deploy some sample application on your cluster. So even if you look at the official documentation, also the same. I think Google is suggesting this is good one. It seems. I never use this one. Okay, so for the Ubuntu flavor, you need to install VirtualBox, download Minikube, the same stuff. Yeah. Version 109, and apply these commands. Okay, this is a JSON output. Probably you can use this one then. So whatever Google is suggesting. So for Ubuntu in Amazon, it is Ubuntu.
We can't run in micro, right? T2 micro. Same thing. The instance type.
Correct. Yeah, you can. And see if I can get you the history. Okay, first I install kubectl, and then I given the permissions, and then I set up the Docker. Okay. Yeah, I think I follow the same documentation. Anyway, so I'll just give this to you. If anyone is trying to follow me, I'll wait for you. Or I'll go ahead. You want to do that later. Start. So you need to just see this message. So the last message, and this is important. Enable and everything is configured minikube cluster. So this will tell you that now your kube and minikube and all install kubectl to start with. Then anyway minikube you can directly access the official link and then install the minikube there. As simple as that. It's a software. You can use any documentation available on internet, the official one of setting up minikube. Here and there, few things you need to refer. For example, I've told so this is Amazon Ubuntu I've used now. This stuff, this will not be there in any of your Google documentation. One software is required. What is that? This 10th one I'm talking about now. Just try to install on your Ubuntu image. And yeah, that's the only thing. And yeah, the remaining thing is okay. So our minikube is ready. Where was our presentation? The first one is run Nginx using this image. So I think Nginx is already there. But first of all, let me see how many parts are there here. Hello minikube, only one pod is there, which is the default one, but I am not interested. So let's try this now. Nginx. kubectl run Nginx image equal to Nginx. So you see a message called pod Nginx is created. Now let's go to the get pods. The status is still showing as containers creating. That means it is still not ready. It is pulling the Nginx image and it is spinning up the container inside the pod. Yeah, now it is up and running. So you can also see the ready status 0 of 1. Here it is showing as 1 of 1. So that means that now your earlier one container is supposed to run inside the container. It was not. Because it was still creating. Here this particular stage is ready. So you can use -o white. We give you more details. How old is this particular pod? So this one is, we just now spent up 47 seconds ago. What is the IP address of this pod? Private IP. I mean, it is not accessible from outside. Private IP. And which node? We don't have multiple nodes, right? We only have one minikube, one single node. Yeah. So we'll talk about nominated details later. Yeah, that is this one. What else we want to check it out? We want to check it out. Describe. Output is a little big, JSON kind of format, I guess. It says that name is Nginx. Now, what is namespace? So, very high level, namespace is an isolated memory inside your Kubernetes, where you can deploy some list of objects. Here we only have pod, but tomorrow we will deploy some deployments, etc., replication controller, etc. So many things will be deploying. All that comes under your namespace. The default minikube right now, because we did not define any namespaces, so it is using the default namespaces. The node, right? The label, IP address. Now this is the container ID. Nginx is the image it was pulled, etc. Initialized volumes are there, no volumes, events. The last one is all about the events. So successfully assigned default Nginx to this node, image pulled, successfully pulled, created the the container. That's it. There's no errors here. Now let's come back with our pod with YAML. Take this one, right? Yeah. So whatever we have so far deployed through manually. So if you want to write a Kubernetes YAML file to deploy a pod, you need to learn a little bit about the YAML files. So all Kubernetes, or we call it as like K8, all K8 YAML files contains basically 4 root level fields. So one is API version, kind, metadata, specification. Now, where can I write these things? If you have a laptop, right? Generally, people generally use this Visual Code. You can install this thing, Microsoft Visual Code, on your local laptop. Okay, and once it's installed, just bottom and go to the extension. Search for YAML. So when you search for YAML, right, you'll get this Red Hat YAML. Here you will see one install option. Just install that, and that's you can start using it. So let me just. This is how it will appear. You can develop this way. You can also and develop Ansible, anything. Visual Code Studio Code is very popular, open source. But before we going into that, let's first of all learn this YAML now. So majorly there are 4 components, root level components. One is API version. Now what is API version is? Kubernetes as and when the version changes. Right now I think what is the version? 1.21, right? 1.22 or 1.20. Yeah, that is the latest version. Huh? So to talk to this API, yeah, you need the latest version because some new features might have installed, some new configuration will be available. So the old API will not work. So here and there, like you need to verify which API version you have to use, so that my language can talk to the Kubernetes. The second one is kind. Kind is what is the component which you are trying to deploy on the cluster? Is it a pod? Or is it any replication controller, or is it some volume? Is it some XYZ, anything? The third one is metadata. This is about the specification of all that stuff. For example, pod details, etc. And then finally specification. Yeah. So by default, Kubernetes having mostly V1 version API. Also, some advanced one they'll be using V1 beta, apps V1 beta, and the list is very big. So based on your requirement, you need to change the API version. Kind, yeah, as I said, it can be a pod or a service, a replica set, or any deployment. In this case, it is pod. Data, metadata, basically about the object. Apart from your name, label, and what K8 expects under it, we cannot add any other under the metadata. Yes, you need to remember that part. So from name or labels and Kubernetes experts under it, we cannot add any other under metadata except that. So in this case, this example, what is metadata here? The string is my application pod. You can give any name, and these labels you can filter based on the labels. For example, tomorrow I have 2 pods running. The labels are given as app, my app, type front end. Then I can ask that Kubernetes, hey, please get me all the pods where the filter label is my app and then type is front end. This is what I was trying. So two things you have seen, and now let's check the remaining two things. So three we have seen now. One is API version, second is kind, third one is metadata, and the fourth one is specification. So you can provide some additional info pertaining to that object into dictionary. So specification, dictionary, containers, list or array. So we can give the cluster list or container list, like in this case, first item in the list, Nginx here in this case. So once this file is ready, now earlier we have seen kubectl run this command. Now it is not that. We will use create and the file name. -f stands to be a switch for, like, what is a file name. Kubectl create -f and so pod definition. Once it is done, you can get pods, scan prod, describe pod by name. What is the name you would have given? My app. So this is an example. Okay. So there are API version, kind. This is the name of the pod, Nginx. So label optional. I am giving labels under the metadata, app, Nginx, and the same type front end. And specification, yes, this is also important. Containers, here this name Nginx, made Nginx is what actually you're going to write. Let me see, it is already there in my machine, or I can manually. Right. Okay. We go to the root. Fine. Looks like it is not there. We can create one. Yeah. So let me make directory. Yeah. So inside this, I'll write pod.12. So instead of here, try to use pod. Now check it out. Kubectl create -a pod by YAML. Nginx is already exist. Okay, so because Nginx is already there, so let me just give a new name. I'll change Nginx 1. So this is where actually we have given the image name. Image name is Nginx. This one. Now get pods. Yeah, Nginx 1 is now running. You got a new IP. Everything is there. So yeah, is there any other ID tools apart from this thing? Yes, we also have IntelliJ. Not sure if it is available in my machine. Yeah, it is also there. This is also one area where people generally used to develop with the code, but I use Visual Code. Also in Linux platform, you have Atom, PepStorm, Python Charm, PHP Storm, Cleon, Rider, RubyMine, AppScure. The list is very big. Many tools. Let's do some exercises. The Kubernetes YAML stuff. So just a recap, the top three root level fields are DB version, kind, and metadata. Yes, specifications also there. So here, yeah, we have seen the same stuff. My app, counter, images, etc. Okay, so you need to help me now. You need to help me to create a pod definition file using the values. So the name of the pod should be Apache. Label should be tag equal to web tag. Container name should be Apache. Image should be HTTPD. Yeah, anyone want to try? I don't want to try. Let's create a file. Or Apache YML. So API case sensitive version. Okay, what is the next row? Kind. And what is the next row? API port root level discuss, no? API, sorry?
Metadata.
Metadata.
Name Apache.
Yeah. What is it?
Name Apache.
Name Apache, right? Okay. And then
Label.
labels. Is it label or labels? Okay, fine. Yeah, so what are the labels you have to give? So let me go to the presentation. Tag web tag. That's the only one I think it is asking to give. Tag. Okay. Container name Apache. So what is the last one? The last one is
6.
okay. So container name is Apache. Image name is
HTTPD.
HTTP.
It's spec, right? Specs.
Ready?
Okay.
Yeah, typo. I'm checking one more thing that now whether it is I have to give this. So this checking labels container, because this is the one single array, right? That is the reason.
Containers text is also missing.
Sorry, where is that?
Under spec, yeah, we need to write containers.
Okay. Yeah. Containers, yes. Generally, we used to write in Visual Code that will help you to solve the problem. For example, word approach, you can just simply copy here. And then this is not required.
I think at the bottom right, we can change that plain text to YML.
Bottom right.
Yeah, the plain text what we see.
Even if you put the extension also, that is fine.
Oh yeah.
I was checking that. I even if you put the YAML, YAML, everything is fine. Uh, it's here, it will even whether we can. So what is error it is showing? The error it is showing that option 1 V1 web tire Apache specification error found in line number 10. What was that? I'll copy from here.
Is equals like, can we specify is equals symbol or only colons or under labels?
Under label.
Tire mentioned like is equals.
What was that error? I forgot. How much is for kind HTTPD? It's been some time I've missed this practice. AP version equal kind for okay. Yeah. Same thing, but looks like in a pod instead of copy, we tried the initial cap. Okay, command to find how many pods exist. Kubectl get pods. How do you find image of a pod? Describe pod. How do you find on which node the pod is running? Describe pod. Give the pod name. How to find how many containers are running in an app? Get pods. Yeah, how do you delete a pod? You can delete pod with pod name. You create a new pod with name Tomcat, image name is Tomcat. I think solution is very simple. So same stuff. Kind pod metadata name. So we use equal here. It should not be. I'm supposed to use colon. Metadata name Tomcat, specification containers Tomcat. That's the solution. So through commands, create a pod with Nginx image. This is one. Yes, find images, describe pod. Yeah, so this is edit a pod. Okay, now this is interesting. So for example, if you have already this pods are running in your machine, you don't know where is the definition file. Can I edit an existing object running inside memory? Yes, you can do that. So you can use kubectl edit pod and so the name of the pod. For example, I want to edit the Nginx one. So you can use kubectl edit pod Nginx one. The syntax will be here and there same with some extra components will be there. We'll talk about that later. For example, what is this creation and timestamp and all this thing, the resource version. But otherwise, you can also edit the existing memory also. For example, I would like to change from Nginx to HTTPD. So you can do this edit and then do modification. The only problem with this edit option is that if you do any changes, right, that will be permanent. That means if I want to refer back the previous part, then you'll be not able to, because you're directly editing the memory. If you don't have definition file, it will be difficult for you to again undo or roll back the changes, etc. there. Okay, so now creating YAML file is a tedious process. Tell me, is there a way so that I can simply generate a YAML file? Yes, there is an option. So for example, I want to create a pod called Redis using an image called Redis 123. So don't want to create it, but I want to create it in a YAML file. So then you can use this command kubectl run redis image name is equal to this one. Use this dry run equal to client. That means please don't talk to the client. Is just dry run -o/yml. Redirect this to the pod.yml file. Just run this thing. So kubectl run redis image up to here. We know the command redis 1 2 3 dry run equal to client -o/y redis yml. What is the syntax issue? Redis. Okay, double hyphen. That is right.
Wide, instead of wide, we need to mention YAML.
Okay. So your YAML is ready. Instead of you struggling, right? Yeah, because long back I've written almost 3-4 months, I think, and I lost my hands on. So AP version V1 kind is spot metadata. Yeah, creation timestamp. That is basically with null labels. By default, it is given some labels, etc. Definitely, this will have some problem. I'll tell you. So kubectl. Now the file is ready. Create -f redis.yml. So let's check it out. You'll see that now Redis is still having some problem. Container. Now you got an error saying that error image full. I would like to understand more about this error. So you can use kubectl describe pod redis. I think that's right. I can know why I forgot the commands. Okay, yeah, this is one. So you can look at the events. So here it is saying that blah blah blah, some image error. The redis 1 2 3 is not there. Basically, that is the meaning here. Now, what I can do, I can use this edit option. Kubectl edit pod redis. Now I'll change this image name to exact name of the redis. Now you check it out. Just wait for some time. I just trying to do what image pull back out. Yeah. So now this is fixed. Likewise, also you can create your own definition file. -yml is this syntax like you need to be little get familiar and all and keep practicing. So we'll do this thing tomorrow. That lab. Yeah. So any questions on this? Okay. Yeah. So tomorrow and the day after tomorrow is the last session, I think. So that you are all DevOps graduated.
We'll get, because of pandemic, there won't be any exams here as well.
And do we have any final assignment type? Raghu? Are you planning anything?
Okay, when for today you're talking about?
No, for our entire training session.
Yeah, sure. So probably this is what I'm looking. Two exercises I'll try to give. One CACD based. One is please. Anyway, I'll be sending out that details. So I need one Ansible role to create load balancers, virtual machines or EC2 machines, and then install components inside that. For example, for a web, separate playbook you need to write inside that role, and then for application service, etc., JDK setups, etc., and then set up the health string, all these things. So this is one project you need to create it for me. So 3-tier architecture you need to set it up along with load balancer. You have to create one one project. That is one. And the second one is you need to create a Jenkins job for like setting up a continuous deployment. So you probably can go with plugins or Ansible, but not the traditional way. So you need to build an image and deploy that to the cluster, Docker Swarm. These are the two things I would like to give. And then probably like after completing Kubernetes, the same second assignment, you can use it in the Kubernetes deployments.
Okay. So what will be the time period to submit the final assignments?
The post completion of the course, probably I'll give you like, I think we'll be completing by 3rd June. So by Monday you need to submit. Sunday evening is the cutoff time.
Okay. Yeah.
So I'll share that communication probably today or tomorrow, and also I'll share a drive where you can upload all your work, so stuff like that, like role and all these things. Or probably I'll try to create one GitHub repository, so wherein you can, along with credentials, I'll try to share with you, so you can upload there as well. For Jenkins and all these things, probably just need to show me the snapshot also of deployment successful creation of the job. Any questions from anyone? All right. So thank you all. So take some rest. I think some of you have taken your first job today. So we'll catch up tomorrow at the same time then.
Yeah, sure. Thank you.
Thank you.
Thank you.